solving a system using elimination. So students tend to super love this strategy. We use this strategy when both equations are written in standard form, or pretty close to standard form. So here's standard form, ax plus by equals c. So standard form, ax plus by equals c. Ax plus by equals c. We will use this strategy even if we're in slightly not standard form, like technically the x and y term could be flipped, we could have a negative a, but pretty close to standard form is what we're looking for here. In order to use elimination, both equations need to be in standard form, and then we are looking for one positive and one negative coefficient that are opposites. Basically, we are looking for the same number in front of a variable, so 5 in front of y, 5 in front of y, one positive, one negative. It would not help me out if I had 5x minus 5y. So same coefficient, same number being multiplied by a variable. One positive, one plus, one negative, so subtraction here. Plus 5y minus 5y. We are going to set this up by writing the equations vertically, making sure like terms are aligned. 2x plus 5y equals 17. And then vertically, I'm going to write the 6x underneath the 2x, vertically aligned, minus 5y equals negative 9. First step, writing them vertically so that the x terms are stacked, the y terms are stacked, equal sign, constant. We are then going to add the equations in order to eliminate one of the variables. This is why we love this strategy. Look what happens. 2x plus 6x is 8x. 5y plus negative 5y. What happens here? The y terms are eliminated. We have 0. We're not going to write 0. We're just going to write nothing. I guess I could write the equals over here, but that's kind of weird. Equals 17 minus 9, which is 8. So generally, you would just go ahead and write that more squished together. 8x equals 8. Beautiful. We have a beautiful one-step equation. So what we end up here is 8x equals 8. This is probably the nicest equation we've solved all year. Our single inverse operation is dividing by 8. And I'm going to write this over here so I have room. Hopefully you're writing smaller. X equals 1. So the first step of elimination is the awesome part. We add the two equations together. What happened is that one of the terms, the x terms or the y terms, one of the pairs of terms canceled, left us with 0, and we have a one-step equation. We are pretty far into our systems unit, so we know that we're only halfway there. We have half of our ordered pair. We know that x equals 1. Our next step, which is the less pleasant part of elimination, is we're going to plug that half of the solution, x equals 1, back into either of the equations. It does not matter which one I choose. I'm usually just going to use the first one. So 2x is 2 times x, where x is 1, plus 5y equals 17. So now we have to actually solve this equation for y. This is the first time we've had to do this when we were finding the second part of our ordered pair, but it's not so bad. Once we do this multiplication, 2 times 1 is 2, plus 5y equals 17. We just have a two-step equation. It looks a little weird though, so just do that multiplication first, and then you will be in a situation with a two-step equation that you're comfortable with. Minus 2, 5y equals 15. And then let's go ahead and do our last inverse operation, dividing by 5. Y equals 3, handwriting malfunction. So divide by 5, I find the second part of my solution, y equals 3. Generally, we are just going to stop here because we do not have a ton of space in general, but on a quiz or if you have room on your homework, it's great to go ahead and check your solution by plugging it in, 1, 3, into the second equation that you didn't already use. So let's plug 1 in for x into that second equation. Minus 5 times y which is negative 9. 6 times 1 is 6, minus 15 equals negative 9. Hooray! 6 minus 15, oh, that's negative. Negative 9 equals negative 9, and I am done. I'm going to check mentally. 2 times 1 is 2, plus 5 times 3 is 15. 2 plus 15 is 17. And yep, I'm confident that this ordered pair, 1, 3, is a solution to both equations, and that means that it is a solution to the system.